So for this first problem, we're told that a man takes 3 seconds to breathe in and out once, and we have a minimum value of 0.5 liters for the function, and we have a maximum value of 4.5. And we're asked what the period is. So the period would be, this is the length of a cycle for the function, just like in general. So here that would be 3, because we're told that this happens every 3 seconds. So the period would be 3 seconds. And the units of the period have to match the units of the input variable. So because this is seconds, we have a unit of seconds. The amplitude is defined to be the maximum output value minus the minimum output value divided by 2. So the max here is 4.5. That's just the second sentence. The minimum is 0.5 and divided by 2, and that gives you 4/2, or 2, and this has units of the output variable, which is liters here. So the amplitude is 2. And the midline is y equals, it's the average of the maximum, or the average between the max and the min. So y max plus y min divided by 2. And that is 4.5 plus 0.5 over 2. And that's 5/2. So 2.5. And this is an equation. It's it's a function. It's a horizontal line. So there's no units here, but you have to have y equals. It has to be a function. So it would be y equals 2.5 for the midline. Okay, and then sketch a possible graph of the function. So we haven't really defined sine and cosine functions yet, so this is a bit mysterious, maybe how this could come up, but later on we'll see that we can do this more rigorously. So we're told that at time 0, because we need to know what the intercept is, at time 0 the volume is a minimum, and the minimum is 0.5. So here we have 0.5, that's the minimum, and the function starts from this point, and then it goes up from here to the maximum value, and then it goes back down, and that's 1 cycle, right? Because you're back where you started, and then you do that again, make a somewhat decent graph, like this. And the maximum value here is 4.5, and the midline is the middle, right? And this is 2.5. So that's like the equilibrium value, and then this maximum occurs, well, this is at 3 seconds, because that's the cycle length, that's the period. So this is 6, and right, because this is the period length, the cycle length. So this peak here is at, you don't really have to label this, but this is at 1.5, and then this maximum there would be at 3 plus 1.5, or 4.5. So that's the graph of 2 periods. Okay, I'm going to do question 3. So estimate the period of the following function. You should probably first verify that this is periodic, and that's also helpful information to answer the question. So to determine if it's periodic, you have to determine a cycle. So the outputs go 5, 3, 2, 3, and then back to 5. So if you look at all of this, actually it includes, we'll go halfway, 5, 3, 2, 3, 5, 5, 3, 2, 3, 5. So each one of these is a cycle, right? it is periodic because this took 40 seconds or 40 input, right, whatever, 40 for the input range, and then another 40 on this side. So because you have a cycle that repeats and the time it takes to do that is constant, it's 40 and 40, it's a periodic function. So, and that actually tells you what the period is. It's 40. Because it's the length of a cycle, and because it's a constant value here, the function is periodic, and this is the period. Okay, and then I'm going to do the first one in question 5. So here you're asked to estimate the period of the function, and you can see here that there's a peak and then another peak here, and this is at, say this is x, this is at x equals 0, and this is at x equals 4. So the distance between them is the period. So the period would be 4, because that's a cycle. You could have measured it in different places. You could have measured it from the bottom here to the bottom there, and that's still 4. But in any case, the period is 4.